Welcome to the Stormsurf video surf forecast for the week starting Sunday, March 17th. Looking at significant wave heights for the North Pacific Ocean, we see the remnants of a gale still producing 25-foot seas due north of Hawaii. Swell from this system is impacting the islands as we speak. Also, another system is developing while pushing off Japan with 37, 38-foot seas, and that is expected to continue across the North Pacific Ocean. So we have a reasonably active pattern in play at the moment. As usual, let's start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they do form, they help direct their track. We're looking for a trough, just like that. That's a trough, pretty pinched one. What that does is help support a counterclockwise flow aloft. That's the hallmark of low pressure, and that's also down at the surface. And of course, low pressure generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, produces surf. All right, so the jet stream finally is consolidated. This is what we want. One flow, a singular flow, pushing off Japan, building with winds to 170 knots, pushing over the dateline, then falling down into a trough here. That's supporting low pressure, which we know is due north of Hawaii at this very moment. Then, east of there, the jet splits with the northern branch pushing up into Canada, the southern branch down over Baja. In between the two flows, as is usual, you get high pressure, and it was a beautiful day in California today. All right, let's move forward. The trough continues to pinch off, less supportive of gale development, but also starts pushing that split point closer and closer to California. And as you see here, when you get into, what is that, about Tuesday night, Wednesday, the little remnants of the trough sneak into California, and that is expected to bring weather to the Central Coast at that point in time. Back to the west, the jet reasonably consolidated, but weakening a fair amount. This area right here, a little bit suspicious. Let's roll it forward. We're into Thursday now, and there you go. See, it starts to split again, but east of there, consolidated with winds 1, 2, 3. That's 160 knots. Another trough building in the Gulf. That would support gale formation, and the split just barely onshore in California. But look at that. It looks like it's about ready to get completely clobbered here. Another trough. The trough building in the Gulf into Friday, that pushing into the Pacific Northwest. Now, here's our split right now. Over the dateline, that would be for Friday, Saturday. So we're almost a week out. But the jet looking pretty consolidated back over Japan. Put this in motion. There you go. Building. Look, it's just this whole area right in here. Very supportive of gale development. We'll see how that, and then it continues. The jet still holding together decently. We're at 180 hours out. Gulf of Alaska, somewhat productive. Split right here. High pressure there, just north of Hawaii. Maybe good for east wind swell for Hawaii. And all in all, not a super great jet stream pattern, but not horrible. As long as it helps support gale formation, we'll take it. All right, so here we are now down at the surface. Surface level pressure, surface level winds. Here's the remnants of the gale that is producing swell relative to Hawaii. It's all but gone. A little tiny area there, that yellow 30-knot winds. And relative to California, at this point, this isn't doing anything either. South winds, 30, 35 knots, targeting wind swell for Alaska. That's about it. New system developing just west of the dateline, 45-knot winds. We'll put this into motion. You also see high pressure north of Hawaii, driving north winds into the islands. The gale over the datelines we get into Monday continues to the east with 40-knot winds. It starts fading off, but gets reinforced by a secondary gale with, 50-knot winds. Again, aimed a bit at Hawaii and the U.S. West Coast. Good solid fetch. This is actually an upgrade from the past couple of days. So the secondary gale, really a storm now, looking pretty solid, winding up in the Gulf, continues into Thursday. Friday, yet another batch of energy starts building into it. Again, with 35, 40-knot winds, looks like a lot of swell generation in the Gulf of Alaska. And yet another system develops off the Kuril Islands as we get into Friday night with 45-knot winds. south of the Aleutian Islands, pushing off to the east, and then that one fades in the Gulf, and yet another system is forecast developing behind that with 50-knot winds. So this is actually an upgrade. All this stuff is looking much stronger this run of the model than it did yesterday at this time. Of course, that will probably be short-lived. The model's always overhyped stuff, but as of right now, a very productive pattern looks to be setting up. Let's go take a look at the effect of those winds on the ocean surface. We're going to start going back in time a little bit. Wednesday night, there's this little gale that developed north of Hawaii. We're calling it a primer gale because this is the first of any significant gale that we've seen in quite a while. Produced 34-foot seas, then faded in the Gulf on Friday. Swell from this system is started hitting California, Northern California, as of Sunday, we'll say about midday. Waves, top spots, 10 foot on the face. Not bad. Solid waves, and winds not too bad in the California area. Now, another system developed behind that with 28-foot seas, and then really started building on Saturday. This one was the main focus. This is for Hawaii. 32-foot seas Saturday, building to 35-foot seas. Continuing, here's max sea height, 35.5 feet there. All the same directly at Hawaii into Saturday night, and then faded Sunday. And here's where we are right now. You can see the front from that system just hitting Hawaii now. Buoys, Waimea Bay buoy, reporting surf heights maybe in the 20 to 25-foot range. Pretty ragged conditions, north winds, but there is surf. And some of this energy, though most of it you can see is aimed southeast, some of it's going to work its way into California starting Tuesday into Wednesday, that sort of thing. All right, so here we are, 18Z Sunday, another system building off of the Kuril Islands, North Japan. Oops, next chart. There we go. Pushing off to the east, consistent 32, 33, 34-foot seas kind of thing. We're into Tuesday morning. It starts fading in the Gulf. Secondary energy builds. We saw that on the surface level charts. Actually, the winds from this one are supposed to build pretty good. We'll see what it does sea-wise. 35-foot seas, 36-foot seas. Yeah, good batch of, let's say, 33 to 35-foot seas forecast. In the Gulf of Alaska, pushing off to the east, some energy into Hawaii. Another secondary batch of energy behind that with 25, 26-foot seas. We're into Saturday. I mean, this is just nonstop, swell after swell after swell setting up. Another system develops on the dateline on Saturday with like 39-foot seas. Now, this one would be from a more northerly direction, pushing over the dateline into the western Gulf, and we're at 180 hours out. Still 30-foot seas, and another one building behind that. Can't ask for much more in terms of just bulk swell generation. The real issue will be weather. So let's go take a look at that. So back to the surface level pressure, surface level wind charts. Here's California right now, just looking at the wind barbs. They're sort of saying north winds at 18Z Sunday. Let's just get it to 0Z. Okay, north winds maybe 10 knots, but even lighter up in Northern California. Hawaii, here's our situation. Due north winds, 10 plus knots. It's probably more like 15 or 20 on North Shore of Oahu. Full chop in effect, but you get the idea. So we'll roll this out. We get into Monday, light winds in California, but see south wind starting to build ahead of this front here. And we know this trough and this low is eventually supposed to sneak its way into the California coast. Now notice as we get into Monday, let's go back. Winds for Hawaii, they're east-northeast early and clocking, holding about 15 knots over the Hawaiian Islands. South winds as we get into Monday night for California. And then we're into Tuesday, south wind mess, 15-knot winds, 10 to 15 knots all along the from Point Conception northward. Hawaii back under the effect of trades, driven by high pressure right there. Now all the focus is going to be here more in the Gulf. Hawaii probably will be protected more. I'm just watching front after front stack up for California. There's northwest winds, high pressure builds in a little bit. Hawaii still under the effect of trades, but look at this low, just filling the Gulf of Alaska. Oh, here's high pressure. Is this north winds for Hawaii? Well, I guess we're going to find out. Yes. It looks like it right along in there. Look at all that fetch just aimed right in this area. North winds, California, as we get into Thursday. That starts backing off some. We're into Friday. Hawaii, east-northeast trades, blowing pretty hard. California, light. There's these little windows in between the fronts, but my guess is the sea state's going to be pretty jumbled. Southern California would probably be the more protected area. So we get into Friday, another front, south winds, Hawaii, east-northeast trades. Get into Saturday, things lighten up a little bit in California, if you believe the models. Strong northeast trades for the Hawaiian Islands. Get into Sunday, here comes another front, south winds starting to tee up off the California coast. Looks that way. Yep, south winds, strong trades for Hawaii, and we're at 180 hours. So, Hawaii, for the most part, pretty brisk trade pattern. For California, north of Point Conception, this rotating south winds, north winds, south winds, north winds with maybe little breaks in between. Southern California, more protected though. Let's go take a look at the rain forecast. So here's our current situation. No rain for California. We're not really focusing on Hawaii from a rain perspective here. And the first signs of rain push into the central coast, we'll say Tuesday night into Wednesday. Snow for the higher elevations of the central Sierra up into Tahoe by Wednesday morning. Continues there all day Wednesday, even into Thursday night. Into Wednesday night. Thursday, things dry out a little bit, but not a whole lot. Another front queues up off the coast. Here we go. Friday, it starts working its way into the coast. Snow, higher elevations by Friday night, and then into Saturday morning, and then that dries out. Are we good for another before we run out of time in the model? It looks like. And as we get into Sunday night, yet more rain for California, another bit of snow. So maybe 3 small snow events for the Tahoe area. Snow accumulations for the week through like the 25th. We're looking at, let's see, Sunday. Well, actually, we'll just go look at it. Here you go. And we go into, say, Sunday night, 16 inches. Okay, and even more beyond that. And looking at the snow levels, you can see high snow levels right now, but as you get into Wednesday, this is the bottom of this Squaw Valley. This is the base of Squaw, and if you have blues and whites below that line, here the reds are liquid precipitation, the grays are sleet, anything that's white or above is snow. So snow the whole way down to the ground every day except for maybe one day. So that's pretty good. And winds not too bad, generally below 40 knots at the peak. So that's not bad, not too bad of a wind situation. In Kirkwood, kind of the same situation by Sunday. We're talking 2 feet of snow or so, 25, 26 inches, and more, almost to 3 feet as we get 10 days out. Snow level profile, all the same. Here's the base of Kirkwood. All of it, once you get to Wednesday, in snow, no rain. Winds, a little bit stronger, 50 knots and some peaks there. And let's go take a quick look at Mammoth. In Mammoth, basically a foot of snow. Again, the virtue of their 8,000-foot parking lot elevation. No rain expected once the snow starts. Winds, not bad, 40 knots. Probably no real closures for that. So, more snow, again, for the Sierra, and rain for California. Not a bad thing. All right, let's go take a look long-term. What's going on with the MJO and possibly El Nino? As usual, we like to look at the status of winds on the equator because that gives us a sign of what's going on with the Madden-Julian Oscillation, aka the MJO. The MJO, when in the active state, tends to suppress trades in the Western Pacific, and that in turn helps feed energy into the jet stream, and that in turn feeds the storm track, and then you get surf, and then you get weather, and you get snow, and all the stuff that most of us tend to appreciate. So, this is the West Pacific here. That's New Guinea right there. East Pacific here. This is the equator, that line right through the middle, date line right there. These are winds from the TAO buoy array. You just look at the arrows and go, yep, they're east, 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 east the whole way across the Pacific. But down here in sort of the southern side of this part of the Pacific, kind of looks like they're either calm or maybe even westerly a little bit. That's suspicious. So then we look at anomalies, differences from normal for this time of year. In the Far East Pacific, a little bit stronger out of the east than normal. But once you get to about 140 west, that's, like halfway to Hawaii. Winds turn westerly, 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 westerly. That all suggests the active phase of the MJO. And the main area we look at is what we call the Kelvin wave generation area, from 135 east to 170 west. So basically the West Pacific. And that's when you get westerly anomalies there. You can create a thing called a Kelvin wave, which is a pocket of warm water. These westerly anomalies take warm water that's normally all pulled up here, driven by these easterly winds. They take all the warm water. Generally, the temperatures are cooler in this side of the Pacific and warmer here because warm water's all been pushed this way by trade winds. When these winds slacken or turn westerly like this, then this warm water starts sloshing east, but not on the surface. It falls depth down 150 meters, traverses the whole length of the Pacific, and then will erupt over in the East Pacific once it slams into the coast of Ecuador and the Galapagos Island, creating a warm pool there. If you get enough of those Kelvin waves over the period of year, that's how you get El Nino. All right, let's go take a look at what the forecast is for winds in the Kelvin wave generation area. 850 millibars, zonal wind anomalies. So this winds up about 4,700 feet, but it's a good proxy for what's going on down at the surface. This is the whole planet on one chart. The Pacific Ocean runs from about this tick mark over to about here, something like that, but it's the Kelvin wave generation area. Between these two tick marks, that's this is the date line right here, and you'll see it right down there, 180, so like from 135 east to 170 west. So you just go down, and this is past in February, and these reds and purples, those are strong westerly anomalies. We had a major westerly wind burst in the Kelvin wave generation area generated by a strong pulse of the active phase of the MJO. That certainly looks like fuel for the development of El Nino, and we suspect that has taken warm water that is in the West Pacific and is pushing it east. Then, as we got into late February and pretty much this whole, March up till about where we are right now, you see blues. That's easterly anomalies. That's the inactive phase of the MJO. And that's not good for storm production, and that explains why things have been kind of quiet lately. But now, here we are. Here's today's date. You see this, red's building again. That looks like that would be favorable for storm development. We say when we have the active phase of the MJO, which this is right in here, it appears. When you have that, that feeds energy to the jet stream. Well, again, the jet stream looks pretty strong. Storm development supposed to be pretty active, at least for the next week, probably more like 2 or 3. So all this looks quite favorable. Let's keep going. So let's look more and see what's going on with the MJO. And we're looking at this chart and you go, well, that looks like a whole lot of nothing. And you're absolutely right. So there's South America, Central America, Australia, New Guinea, Kelvin wave generation area right in here. When you see these yellows, this is outgoing long wave radiation. Yellow means positive anomalies. That means more sunlight reflectivity. That sort of means that's not the active phase of the MJO. The blue is the active phase of the MJO. And this, per the statistic models, the forecast, you just see basically no sign of any real MJO activity, just dead quiet. That's kind of a head scratcher. And then you go down here, this is the dynamic model, the GAFS. It says the same thing. Why would that be? And yet, why would the jet stream be doing pretty well? And why would all of a sudden we have a whole bunch of storm activity? Well, when El Nino starts getting a hold on stuff, it sort of acts like the active phase of the MJO. But what it does, it takes the MJO and just dampens it out completely. And right now, the MJO, by both models, and for the next 2 weeks, looks to be exceedingly weak. Let's keep that in the back of our mind for a minute while we dig a little deeper. Phase diagrams, another way of looking at the MJO. So assume this circle assume this is the North Pole of our planet. The MJO moves from west to east, from the Indian Ocean over the maritime continent, across the West Pacific, under the United States, across the Atlantic, through North Africa, back to the Indian Ocean. This is the path of the active phase of the MJO in February and now March. You can see the dates, March 1st, 2nd, 3rd, 4th. Here's where it is right now, where the heavy dot is, and here's the forecast track, and it looks like the MJO is supposed to be dead sound asleep. This per statistic models. The dynamic model says the same thing. Dead, not inactive or active, just a dead MJO, very weak. If it's within the circle, the MJO is very weak, and it's just listless in here. That sort of leads credence to the thought that maybe El Nino is pulsing a little bit. This is the 40-day upper level model. The areas where the green is are areas favorable for precipitation. So one could loosely say that's the active phase of the MJO. Well, there's New Guinea, there's Australia, here's the equator right there, and there's South America. We see greens. This looks like the active phase of the MJO per this one, or at least areas favorable for precipitation right over the core of the Kelvin wave generation area and moving east slowly into Central America by April 11th. That means pretty much the whole month of the remainder of March into early April, influenced by the active phase. Inactive phase starts building the West Pacific April 1st. It makes its traverse. Takes 3 weeks, 4 weeks to get across. So April 1st to, what's this? It says into Central America, we'll say by the 21st of April. That's 3 weeks, sure enough. Then another weak active phase after that, starting April 11th and making it to the Central Pacific by April 26th. So a little bit stronger pattern indicated in this model. The CFS model, okay, again, this is the whole planet on one chart. Kelvin wave generation area, generally between these two tick marks. Solid contours are the active phase of the MJO. Dotted contours, the inactive phase. So you can just see active, inactive, sort of an active, and it elongates. Here's the inactive phase that we've been in since, we'll say, early March, and it's getting ready to fade out. Here's the active phase building, pushing into the West Pacific as we speak here, according to this model. The reds are westerly anomalies. You can see here's that giant, strong westerly wind burst in February. We see this one expected to be a bit more modest, but just solid, continuing for the whole month over the Kelvin wave generation area. That bodes well for a long run of swell production and possibly rain for California. So California's at 120 west. You can see pieces of westerly anomalies pushing into the coast. When that happens, you tend to get precipitation, and maybe isn't limited to California either. It could go up into the Pacific Northwest. So like this one here, when this pushed into the coast, there was snow the whole way, Pacific Northwest, California, the whole thing. These not as robust later in the season, but still windows of opportunity right there. All right, one more model. Longer running version of the CFS model, 850 millibar wind anomalies. This is upside down. Past performance is down here. So, and Kelvin wave generation area between these two tick marks, just going straight up the chart. Here's that big westerly wind burst that happened in February. And you see that, and you go, that looks pretty solid. But what is this monster here? This is a projected westerly wind burst in the May, April, pretty much the whole April time frame. Interesting. All right, so before we go look at that, where are we? Here's where we are today. Right now, very weak westerly anomalies, easterly anomalies fading out from the inactive phase, dissipating. So we'll overlay the MJO. There you go. Dotted contours of the inactive phase. Here's the building active phase of the MJO. Should really start taking over by, let's say the next week or so. And once that happens, westerly anomalies are supposed to really start building, but then we just get into this full-on westerly wind burst mode, supposedly, in first week of April, the whole way through almost the end of April. And then we have this inactive phase thing. Westerly anomalies continue, and they just go right on in. So when you look at this, you just go, when you see westerly anomalies like all that, here, we're going to take this off. Westerly anomalies like that, and pretty much pretty consistent. It hadn't been as strong in like December, January timeframe, but the forecast is pretty impressive. So we'll overlay the MJO. Now do the low pass filter. And what this is suggests an area favorable for low pressure. You call it a low pressure bias. You see it had 1, 2, 3 isobars. So El Nino was building back until about mid-December, and then it kind of lost its mojo. And you notice the surf just basically took a nosedive during that time period. No matter what the MJO was doing, the low pressure bias or the El Nino bias is considerably stronger. And when the El Nino bias was like losing its momentum, lost its, all its forward progress, the storm track just fell apart. And then in February, sometime in February, see this, 1, 2, the third contour line reappeared just like it did down there. And as of right now, we're back in the groove. Took a little lead time to get going. What was that? About a month. Once it does that, hey, momentum reestablished. We're on a roll. And according to this, now this is really fluky, but a fourth contour line is supposed to develop from April on into almost June. This has been on and off the charts. Don't know if it's real. Don't believe it. But this westerly wind burst thing has been pretty consistent on the charts. So we'll say generally this whole, we'll call late winter, the whole spring, looks pretty favorable for storm development. And that is a good thing. All right, enough of the MJO. What's going on in the ocean? Now we're going to start talking El Nino. This is real long-term kind of forecast stuff. All right, so this is, again, from the TAO buoy array. This is the East Pacific. This is the West Pacific here. This is subsurface ocean temperatures on the equator. These little these lines going down, this is the anchor lines in the TAO buoy array. The X's are the sensors on those anchor lines. All right, and you can see this is 30 degrees, 29, 20. So we'll just go 29, 30 degree centigrade temperatures. That's warm temperature, as always, in the West Pacific, making it to the date line. The 28 degree isotherm line has been, at one point when things were really active, is at 150, and then when we lost all our mojo in the ocean, it retreated back to 160. What's happening now? Boom, it's to 145. This is maybe the furthest east it's been so far of all last year and into this year, suggesting warm water is on the move. The 24 degree isotherm line was up about barely at 25 meters. It looks like it's down to maybe 30 or 32 meters or something. I mean, it's hard, it's just a wild guess. But you get the sense warm water is building into the East Pacific. And we can look better at that by looking at anomalies, differences from normal for this time of year. What do we have? Well, you can see we have the entire upper levels of the Pacific are warmer than normal, with this one pocket, generally this whole area here, 4 degrees, 3 degrees, 3 degrees. This is like a double barrel Kelvin wave that was over in here and has been generated from the February westerly wind burst, and there was actually another one in like late January. And it takes about 3 months to make its way across the Pacific, but it looks like it's already starting to impact maybe the far eastern Pacific, and probably month and a half of upwelling still to go. A lot of warm temperatures going to be built. If you want to start an El Nino, this is exactly what you want to see. Here is another modeled version that even more pronounced. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 5 to 6 degree. Oh, actually, you can see it. There's a 6 degree pocket embedded in there. So this is a very, very warm Kelvin wave, and filling the whole way from, what is that, about 105 west back to 145 east. Basically, the entirety of the equatorial Pacific has warm water under it, pushing off to the east. If this was ever a time bomb or a fuel for a El Nino-like fire, this is exactly what you'd want to see. Here's another way to verify that. This is from like JSON 2, JSON 3 data. And strip out all the waves, strip out the wind waves, strip out the tides. So that's South America, Central America, New Guinea there. That's the equator. There's the date line. And what this means, this is centimeters above normal. So the ocean is higher than normal over the entire equator, with this one core to like 10 centimeters above normal. So, okay, warm water expands at depth. If we know there's a big pocket of warm water here pushing off to the east, it expands. It's going to create a bump on the ocean surface. The satellite data basically confirms that. Remember, this water is down 300 feet down in the ocean. So, you either someone's got to swim down there, or you got to have an anchor line with thermometers on it, or the other way to do it is infer it. whether it's there or not. And this bump on the ocean surface, and a 10-centimeter bump is a pretty big bump indeed. That clearly confirms there's some big Kelvin wave here pushing off to the east. Upper ocean heat anomalies for the past year, right? Okay, so you can sort of see warm water, April of last year, pushing from west to east. That's like a Kelvin wave. Weak Kelvin wave. We'll call it Kelvin wave number 2. Pushed finally into the Ecuador in the July time frame. Stronger one last fall from westerly wind bursts in the West Pacific, taking warm water, pushing it off to the east. It arrived right around Christmas time. Okay, Kelvin wave number 2. Then here is the more interesting one. We thought this was pretty solid. This is Kelvin wave number 3/4. 2 different westerly wind bursts feeding it, but we'll call it Kelvin wave number 3. And look at the core of the heat here. A lot stronger in that one. Certainly a lot stronger in that one. In fact, I would call this a progressive Kelvin wave pattern. Each Kelvin wave looking stronger, more pronounced. Also notice in between Kelvin waves, you get this sort of cool water upwells a little bit. Here's another, these 2 Kelvin, cool water upwells. That's actually, and that was yet another upwelling from a previous Kelvin wave. So this is the Kelvin wave in flight. Has not made it to the east side of the Pacific yet, but it's on its way, looking pretty positive. All right, so let's see what's going on at the ocean surface. And here's South America right here. Here's Peru. What is this? Much warmer than normal water, building strongly along the Peruvian coast up into Ecuador. Now we've got this little finger of cool water, but just in the past 24 hours, that has collapsed significantly. It was pretty strong there for a week and a half or so. Looks like it's fading. It's collapsing quickly, probably under assault from lots of warm water upwelling, maybe the leading edge of that Kelvin wave that we were just talking about. Also notice all this warm water out here, not super markedly warm, but building and in the kind of classic El Nino triangle shape type thing here. We'll look at that more in a minute. So things are looking more like El Nino now, and we're in March. Typically, this is what you'd expect to see this kind of a building pattern in, May or June or something like that. We're in March. The question is, will it hold? We suspect it probably will, especially given the persistent low pressure bias over the Kelvin wave generation area. But anyway, pretty favorable looking pattern. Over here in the West Pacific, there's New Guinea. Yeah, warmer, but not that warm. All the warm water that's normally over here appears to be building into the East Pacific. That is a definite sign of El Nino. The trend for the past 7 days, 3 days ago, there was no warming anywhere to be found here. The yellows now suggest a modest, gentle warming pattern, again setting up over the equatorial Pacific. That's good. Here's our little patch of cooling water. It is steadily getting smaller. We actually see this little bit of warming happening right here. It almost seems like there was like some of the northerly wind bursts that came here and caused upwelling. The sense is that's probably fading now. It was probably localized. Not sure. But either way, it's disappearing, and that's what we want. Now here is, there we go. Here is the, actual overview, and still there's that cool water patch, but we think it's shrinking, not as strong as it was. Here's your warm El Nino-ish signal, if you will. Not super defined. I mean, if you were in some really big El Nino, you'd see reds up in here, bright oranges at least. We're nowhere near there. If anything, this is maybe just the begin. It's either a mixture of leftovers from last year's failed El Nino attempt and maybe the beginnings of another push. I mean, typically when El Ninos get started, if they're pretty strong, they start in the February-March time frame. This is what they call the spring unpredictability barrier, because you're never really sure. The models don't have a good handle on what's going on. That doesn't mean that the ocean doesn't know what it's doing in the atmosphere, but the models don't have a handle on it. But we see a general warming pattern. Even if it's not El Nino, warmth in this area feeds the jet stream, that feeds the storm track, that brings moisture into California, and that appears to be where we are at the moment. Temperatures in the Nino 1.2 region. This is the area right up there along Peru and Ecuador and the Galapagos. You can see it's very noisy. They've been bouncing all around since December. And here is that big spike of that cold water. But you see, it's rebounding quickly in 1, 2, 3, 4, 5 days. We're up back into positive values, half a degree, 0.474 above normal. The official El Nino monitoring region, the area from basically south of California out to the date line, 5 degrees north and south of the equator. You can see we've been hovering about half a degree above normal. But then in March, we're building a little bit. Current value right today, 3/4 of a degree, 0.756 above normal. But we've been up to a 1 degree or even 1 1/4 degree above normal. So basically, if you were to put a trend line through this, it's pretty much flat at half a degree. Then somewhere around late February, it started ticking up a little bit. We'll see what's really going to go on. So what effect are the warm temperatures on the equator in the East Pacific having on the atmosphere? One index of that is the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When the index is negative, today it is minus 9.10, that can be just a sign of the active phase of the MJO. But El Nino is like a long-running active phase of the MJO. If it persists over time, then maybe you have El Nino. So just looking at the daily numbers, we were down at 14, and we were actually down at minus 43 in February, that big active phase of the MJO. And it kind of backed off and withered a little bit. But it kind of, we're just in this persistent negative kind of state, which is good. That's exactly what you want to see. That means pressure is lower in Tahiti. That means the Pacific Ocean is sort of in this persistent low pressure bias, just like we were talking about earlier. Okay, but that's noisy. Daily numbers. 30-day average, minus 14.02. Okay, that's good. And the interesting part is, look at this. It's been down at below minus 10 for coming up on almost a month now. That's kind of a long time for the active phase of the MJO. Interesting. 90-day average today, minus 5.42. If this was down around minus 10 or 15, we'd say, hey, we're in El Nino. But you kind of look, okay, a month ago we were at positive 1.37. But what this sort of smells like is low pressure it's not El Nino status, but it's trying to get a foothold and digging out and having some persistent long-term effects on pressure in the Pacific Ocean in the area, we'll say north of Tahiti, which is like the core of the Kelvin wave generation area. That's exactly where we want to be. You can look at the graph here and see the 30-day average here dropping for the past month. The 90-day average dropping slowly. So we're on a good trend line for the moment. Let's go look at one more indicator. This is the ESPI index, difference in not a temperature, but rainfall between the area north of Australia and the area basically over the equatorial Pacific. You want to see if you have warm water over this area, which is what we're trying to get, on the ocean surface, then theoretically you have more evaporation. Theoretically, you get more precipitation. When this index is positive, that means it's wetter here than normal. When it's negative, it means it's drier here than normal. All last year, it was negative, drier than normal. Though El Nino was trying to get going, it just really couldn't evoke any sort of atmospheric response. In the past month, now today we're at 0.33. This actually was up at 0.9, I think, or something like that a month ago. So it's lost some ground. It's not overtly, let's see here, it's not overtly suggesting piles of moisture or precipitation here, but, basically neutral. So we're between the two indexes and everything else we're saying, well, we're still neutral. We're not El Nino, but we're kind of getting more aligned towards El Nino. And then finally, the forecast from the CFS version 2 model. Sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region. This is ocean surface temperatures between the area from south of California out to about the date line. And you can see the trend here. Sea surface temperature is steadily creeping up from La Nina, weak La Nina. It was actually 2017. 2018 was get us neutral year, and maybe a little bit more, which it did, into weak El Nino territory. Here's where we are today, supposedly 1 degree above normal, a little bit more, and the forecast is all the way through the summer, building to 1.5 degrees in July, and then sort of slowly trickling off to 1.4 degrees in October, and then maybe fading as we get into December. So it looks, according to this model, but this model has kind of overhyped this thing all along. We'll say a general steady warming trend through the entirety of 2019 seems possible. So what's that mean? Well, that means this summer things could do pretty well. Southern Hemisphere responds to El Nino pretty well, and maybe we'll get a little bit more than normal Southern Hemi swells. We're certainly, the short term, looks like the North Pacific isn't giving up anything anytime soon, so we'll take that as well. And then the real question is, what happens when we get into the fall? Well, if you've had a persistent long-running warm pattern and ocean temperatures stay warm, and you've got westerly anomalies and the low-pressure bias and all that going on in the Kelvin wave generation area, seems like the fall, this coming fall, should be pretty active. Hurricane season, probably pretty active too. So, something to consider. So, for the short term, looks like a pretty bountiful flow of storm activity on the charts for the next couple of weeks, aided by the active phase of the MJO and a little bit of El Nino push. We could be in for 3 weeks to a month of swell and some snow and some other stuff going on, which is good. Longer term, beyond that, doesn't look like El Nino is going anywhere. I mean, we'll call it El Nino, but it's not really. It isn't a strong El Nino. But we kind of like that. This long, slow, momentum building kind of thing. Get us in a groove, get the jet stream going, realign it a little bit, and let's go like this for a couple years. We're perfectly happy with that. And by that, we mean not just the winter months, summer months too. Southern Hemi will respond, could be an active pattern. Basically, this affects the entire Pacific Basin, all seasons, and all favorable for surf, storm production and surf, and then in the winter months for precip into California. So that's our forecast for this week. Looking quite positive too. We'll do it again next week, same time, same channel. Thanks for watching.